Okay. So today we will complete the rest of the section B, that is linear functions, right? Because most of the time we start with a linear function in economics or econometrics also to explain different econometric issues and concepts, right? So you can see the methods we apply which require that we will be able to represent the equation that describe our models as linear functions, right? So we study simple functions in this form, right? Y is equal to beta naught plus beta 1x, right? So suppose for example this is the model which we are trying to represent. Y is a mutual fund return and X is the return on the S&P 500 stock index. Basically you can take this as a Nifty. Okay, is it clear, Ajay?
Sir?
Means this Y is the variable. Basically it is saying it is a mutual fund return. Okay, means
Yes, sir.
there are different type of mutual fund. Okay, and you can consider the mutual fund. Do you know what are the different type of mutual fund? Indices are there or returns are there? Let me tell you.
Mutual funds are categorized by asset class.
One second. Go to Google Finance. Is it visible, Bhaktiman?
Yes,
Yes,
sir.
sir, visible.
Okay. There is this like Google Scholar. You can go to Google Finance. Okay, and there you can see like in the examples which we did. You can see Nifty 50 is there, isn't it? Sensex, Nifty Bank, Nifty IT. So these are basically market indices. Okay.
Yes, sir.
These are basically what it is saying. These are domestic benchmark indices. Okay.
Yes.
So basically this shows the movement. Basically whether the market is doing well. In general, Nifty is for Indian whole. You can say comprises of 50 best stocks. Comprises of almost various industry. Okay. So
Sir, it includes both and government, non-government, all the company taken together.
it is like public limited, like
Yes.
whether it is a government owned or largely private owned, but most important is it is
Public limited.
public limited companies. Okay, so there is a difference between public limited and government owned, public owned, right?
Sir, basically Nifty 50 means the top most 50 companies, no, sir?
Yes. So you can see it is actually top 50 companies, but they comprises from different sectors like bank, like Bhakti Madam, as Bhakti Madam told, PSU banks are also part of it. IT sectors are also part of it. Healthcare sector, FMCG, power, utility, various you can say industries are represented in terms of 50 companies. Okay. So suppose, but let's say that if you want to search mutual fund return, suppose let's say that in India, okay, suppose you can see S&P is the US, you can say, okay, Standard and Poor. Similar in US, it is called S&P 500, okay. So if you will go to the mutual fund, you just see mutual fund. If you will go to the mutual fund, let's say so you can search over here. Let me type mutual fund return India. Let's say that if we search. It will give you different type of some of the popular mutual funds names are there, but I think you can see mutual fund categories. Can you see? There are many mutual funds, large cap companies, flexi cap companies, mid cap companies, debt companies. Okay. So suppose for example one large cap companies which invest, this fund invest in the big companies. So it is called ICICI Prudential Large Cap Fund. So it has given 21% return over 5 years. So similarly various other mutual funds returns are there. Is it clear, Bhakti madam?
Yes, sir, clear.
So basically like why I have shown here, because I thought those who are not actually coming from the financial economics or finance background, you will not able to relate this variable. Y is a mutual fund return. Let's say that if you will take Y as large cap return, let's say that this index, ICICI Prudential Large Cap Fund. Okay, you can take like that, and your X is the return on Nifty 50. Okay, so now what you are trying to explore over here. So when your Nifty 50 is increasing or decreasing, whether it has any impact on the ICICI Prudential Large Cap Fund return. Okay, because as an investor you should know this, right? So this is how you model the data. So now let's say that you got this equation. After you run the equation, means you take the data of y and x, and then you got beta naught is your intercept and beta 1 is your slope, right? So this beta naught is minus 0.005. It is the constant or y intercept, and beta 1 is the 1.1, that is the slope, that is delta y upon delta x, right? So delta y is what? Because your y is the mutual fund return or ICICI Prudential Large Cap Fund basically, and S&P 500 is your, let's say that we have taken Nifty. So basically this is what your slope represents and this is what your beta naught represents, right? So now slope you can write also, because already we know that beta 1 is equal to delta y upon delta x. So delta y is equal to beta 1 times delta x, right? And for linear functions, you can interpret like this. The marginal effect of x and y is constant and it is equal to beta 1. So basically for linear functions, our slope remains constant, or slope, or we say the marginal effect of x on y, because you can see over here delta y is the numerator and delta x is the denominator, right? So whenever, because usually in the regression we try to see the impact of x on y, so that is why the beta 1 is interpreted as the marginal effect of x on y, that is largely constant in a linear function, right? Is it clear?
Yes, sir.
Now suppose for example what you can do, one exercise you can do. Suppose if I will give you a data of y and x, you can do it in Excel. You estimate this equation beta naught and beta 1, okay, and see whether the slope, if you will take the delta, once you estimate y, then you predict, because based on the beta 1 and beta naught you can predict the y hat, right, the regression line, correct? So once you calculate the regression line, then you can find out whether the slope remains constant or not. That we will see. We'll take one example and you can do the exercise also. Because ideally you might have done the exercise like many times by taking various linear functions, but whether the slope remains constant or not across the data points, so that you can practice, and you can show it to me also, linear function practice. And
ଗୋଟେ ଡାଉଟ୍ ଥିଲା
ହଁ,
ଯେ ଆମେ ଏଷ୍ଟିମେଟ୍ କରୁଥିଲେ ଯୋଉ
and
ଷ୍ଟାର୍ଟରରେ ବିଟା 0 ବିଟା 1 କରୁଥିଲେ ସେ OLS ମେଥଡ ହିଁ କରୁଥିଲା। ଆମେ ଯଦି ଏକ୍ସେଲ ରେ କରିବା ସେଠି ମାନେ କଣ କିଛି ଏମିତି ଫର୍ମୁଲା କହୁଛି ରିଗ୍ରେସନ ର ଏମିତି କଣ ଦେଇକି ବାହାର କରିବା କି?
okay, like ମୁଁ
ତାପରେ ବିଟା 1 ର ଫର୍ମୁଲା ଟାକୁ ଲିଖିବା, ବିଟା 0 ଫର୍ମୁଲା ଟାକୁ
ନା
ଲିଖିବା।
ମୁଁ ସେଇଟା ଲେଖୁଛି, ମୁଁ ଆପଣଙ୍କୁ କହୁଛି, ଯେମିତି ମାନି ନିଅନ୍ତୁ yesterday we are doing let me take one example. If we will go to, let me see, one example, let me check if I can take one example. This is how you will be doing it actually in Excel. Okay, is it visible?
Yes, sir, visible.
Suppose let's say that you have taken these are the number of observations, 5 number of observations are there, right? Maximum. This
Yes,
is
sir.
your y, okay,
Mm.
and this is your x.
X1.
So you will write like this: sum, then as I told you today also,
Comma ball.
okay. So this is then you will calculate y bar, then x bar, then sum xt yt, sum xt square. I will come to that. So suppose, for example, first what you will do. So what is this? You can see over here. This is basically
C2, C2. Right.
C2 plus C2. That is,
YT plus X1T.
huh. So this is a different data, but we can take this. But right now it is not required. I will come to this table later on. What is this actually? But let us first try to understand. So how you will estimate? Okay. So what you will do is you will take fresh data. So do you have the Gujarati book with you? Let me show you. We will take one Gujarati book data, that is better. Okay. Let me show you. One second. Because if I'll give you the book also if some of you are not having the book. Suppose, one second. Gujarati data set, let's see. This is one data. I have to check, but this is, I think, already must be there. Yeah. This one is there from the Gujarati data set. I am telling you, this book is very important. I have all the data sets, so don't worry about the data. We'll do it. But this book I will give you. So whenever we will be doing any exercise, you can keep this as the first. You can say from all these I think data will be using to learn econometrics. Let's try to understand. This is, I think, it will be there in the chapter number 2. I think earlier also I told. I want this chapter and exercise also we will be discussing. Later on I will come to that. You can see this data, madam. Bhakti ma'am. Okay?
Yes, sir.
This 3.3. What you can do is, this 3.3, you can take y you enter, because this one I am doing it from table 2.4, if you have remember, in the Gretel. Okay, this is coming from the Gretel data. I'll just show you. This is there. If I remember, I am using from Gretel this data. Table 3.2.4. I have remember this. Can you see over here?
Yes, sir.
Y is equal to 70, 65, 90, 95, 110, 115, 120, 140, 155 and 150. Isn't it? This is coming from there, 2.4. But you just see x I have entered, y I have entered, then I have written summation, then x square, then y square, then this is small xi, means deviation form, x minus x bar,
X bar.
then y minus y bar, then xi into ia, okay, then xi whole square, then yi whole square, okay, then yi cap, the predicted values of
Predicted
yi.
value.
So how I got? I will send you this this workbook. You can practice. Just change the x and y and see how it is happening. Then you do it in another workbook. Okay. And also you try to without using stata inbuilt function, you try to estimate it. Means calculate everything in stata with a do file. Okay, Bhaktima?
Okay, sir.
After the class, you write a code to estimate all this.
Yes, sir.
At least first beta 1 and beta naught and beta 1.
Yes, sir.
Bit.
Okay, sir.
So, I will send you this file, not a problem. So, let us see. Okay, the same thing is done. It is done manually also and here also. Separate, different data I have practiced also here. Okay. So, I was trying to tell you from here. So, you just see over here.
Yes, sir.
X bar already we have calculated, y bar we have calculated. Now, intercept formula already we know. That is y bar minus beta
Intercept.
1 hat into x bar. Okay. So, the slope is beta 1 hat. Okay.
Okay, sir.
Just 1 minute.
D.
Okay. Slope formula is summation xi yi. First, you need to calculate the slope.
Beta 1 hat. Yes,
Beta
sir.
1 hat. So, beta 1 hat is nothing but the slope.
So, nice.
The slope you can see how we have calculated the slope. The slope we have calculated like h13 divided by the i13. So, h13 is nothing but
XI.
summation xi yi. So, small summation xi yi means that is the deviation.
Division.
Okay, and I13 is your you can say xi square, okay, that is summation xi square 330. You can see over here, once you divide it you are getting the slope. Okay, and intercept you are getting like also the same way already as I told you, because you need slope to calculate the intercept. Then I have written the consumption function like this. So because that is 24.4545. This is this value plus 0.5090 x, and you can see I have calculated the correlation coefficient also from here, the covariance here, then the variance of beta naught, variance of beta 1, r square, then sigma square. So all this, Bhakti ma'am, you have to calculate, but gradually.
Yes, sir.
First step is you calculate the regression line, okay?
Yes.
Then you calculate the error term. Then you calculate the error term square. Okay, ma'am?
Yes,
So this one
yes, sir.
I will say you take this data only and see whether you are getting or not.
Yes, sir.
So now coming back to so that is why you keep this one is you can see the same data, I think. Let us see. No, it is little different data, but you just cross check, ma'am, this data, and because the beta 1 NAT we are getting here the same value, and beta 2 I think little different, maybe, I know, yeah, almost same,
Yes, sir. Some
but the
differ.
numbers are little different, right?
अच्छा जे consumption data differ करूची.
8 9 but data is different, but the result almost is same. Okay, that will cross check why it is so. Okay, because there it is, I think 8 7, it is here.
80,
Okay,
150. Here is right. It 10 times.
no, it is not.
Oh, 10 times of consumption data is there in the table.
Hmm.
In Excel it is 8, in there it is 10 times of 8. That's why sum is 17,000, but in Excel 170.
With x you just see here x we are having 8 80
10 times of
100, and here we are having 8
8.
10. So I think this is a very good example of change of scale, whether our
Yes, sir.
regression means the slope is independent of change of scale and change of origin. This is a very good example, isn't it, ma'am?
Yes, sir.
So what we are getting over here? Is it independent of change of origin and change of scale, or change of scale? Because here we did the
Change of
scale.
scale.
Is our slope is independent of change of scale?
Slope.
Slope. Beta 1 hat
Okay. I don't
means
know.
beta 2 hat basically.
Beta 2 what?
No, in the Excel it is written beta 1 hat. Yes, not beta 2 hat. In slope, I have written clearly slope. Is the slope is independent of change of scale or not? Let's see.
It will not independent of change in scale. Oh, it's change in scale. X develop 1 unit.
Let me see. I think it has changed actually here. I'll come to that. Okay. So why it has changed or not, we will discuss that. Okay, Bhakti ma'am.
Okay, sir.
Because the formula here, and I have to relate. I have to check the data. Okay, once. Because here it is, I think, little different. I think all the data points you have to cross check. Okay, but let us focus on today's session. The change of scale I will discuss later on. Let me check. Okay, because for that I think we have to. I have not cross checked the data. So I hope this is you can estimate it the intercept by straight away applying the formula. What is the formula? Beta naught hat is y bar
Y bar
minus beta 1 hat x bar. So at this point of time, only we need this. Later on, we will go to little advanced topic. Then, but to calculate this, you need this. But beta 1 hat you need first. That is summation xi yi upon summation xi square.
Yeah.
Okay. So, as already we know that your beta 1 hat is delta y upon delta x. So, delta y is nothing but it is equal to beta 1 hat into delta x, isn't it, Bhakti? So, what we are saying, most important is the interpretation. Today's session, the focus is on the interpretation. That what we try to see over here, the marginal effect, because beta 1 is the slope, right? So it measures the effect of the change in x. What is the effect of change in x on y, right? So we say marginal effect of x on y is constant, and that is equal to beta 1. Okay, so beta 1 is constant over here. Second, when we will go to multivariate then your y will take the form like this. It will go up to beta naught is your intercept, beta 1 x1 first independent variable, second independent variable, and it will go up to the kth independent variable. Clear? So this is example where let's say that y is the house price measured in dollars, x1 is the number of square feet of the house. Okay, so here we are trying to see the factors affecting the housing demand. Okay, or you can say this is, then x2 is the number of bedrooms, x3 is the number of square feet of the lot, x4 is the number of bathrooms. Okay, so this is a basically multivariate or multiple regression model. So suppose let's say that beta 1 is equal to 0, you got. Then how you will interpret? Here also you interpret in the same way. When you interpret a multiple linear regression coefficient, basically here you are interested to interpret the only x1, okay, the impact of x1 on y. So you will be saying holding x2, x3 and x4 constant, the marginal effect on housing price of adding to a house square footage is delta y will be equal to beta 1 times delta x1, that is 10 times delta x1. Is it clear, Bhaktima?
Yes, sir, clear.
Even though there are other independent variable, but we only focus on the variable which we are trying to interpret. Okay?
In short, each beta explains the partial effect
Partial
of the
effect.
particular variable.
Yes.
Partial, that to marginal.
Yes, yes. That is why. So that is why interpretation is very important. Because I at the same time I cannot say that together they are affecting y. I have to keep them separate when I am trying to interpret actually the impact of x1 on y.
Okay, so from this model, from the we just can say it is the partial effect. Together they are affecting or not, that is not possible to say. Claim. Not say claim here.
Yeah, that is why regression is not always a causality. We don't see the causality. We only try to estimate the impact of independent variables, or we try to predict the impact of independent variable on the dependent variable, isn't it? Is it clear? I think for others, Ajay,
Yes, sir, it is clear.
Madhusinda,
Yes, sir. Clear, sir.
Chinmay.
Yes, sir. Clear, sir.
Okay. So this is.
ସରି ସାର୍ ଟିକେ ଡିଷ୍ଟର୍ବ କରୁଛି ମତେ ଲାଷ୍ଟ ଟାଇମ ଷ୍ଟାର୍ଟରେ ଗୋଟେ ଆସାଇନମେଣ୍ଟ ଦେଇଥିଲେ ସେଇଥିରେ ଗୋଟେ ଲେଖିଥିଲେ କି ସେମାନେ ଜଏଣ୍ଟଲି ଆଫେକ୍ଟ କରୁଛନ୍ତି କି ନାହିଁ तो ସେଇଥିପାଇଁ ଆମେ କଣ କରିଥିଲା ଏଲିମିନେସନ ନା କଣ ମନେ ପଡୁନି ଏମଏଲଏସ୍ ୟୁଜ
Restricted
କରିବୁ
model.
रेस्ट्रिक्टेड
हाँ.
मॉडल हाँ
ରେଷ୍ଟ୍ରିକ୍ଟେଡ ମଡେଲ ୟୁଜ କରିବୁ ଆନ୍ସର ଆମେ ରେଷ୍ଟ୍ରିକ୍ଟେଡ ମଡେଲ ୟୁଜ କରୁନଥିଲେ ଏମଏଲଏସ୍ ମଡେଲ ୟୁଜ କରୁଥିଲୁ ଏମଏଲଆର ମଡେଲ
हाँ मल्टीपल लिनियर रिग्रेशन मॉडल
रिग्रेशन मॉडल
हाँ आमे आसीबा सेत्रु का आसीबा एठी फास्ट हमर एठी फोकस होउची जे लिनियर फंक्शन आमे जतले भी रिग्रेशन एस्टिमेट करू थांते लार्जली आमे स्टार्ट करंते लिनियर फंक्शन लो व्हिच इज मोस्ट इजीएस्ट वन and what will be the interpretation of beta 1 means basically the slope over here because that is the largely we are interested because whenever you will be writing a research paper also we don't see every aspect of the regression because people will be more interested in this beta 1 beta 2 beta k and so on. Okay Bhakti ma'am?
The effect
Yes,
of
sir, yes,
each
okay.
individual variable on the dependent
Dependent variable. Okay.
सर एठी एते जाक वेरिएबल लाभ कोन हम कंबाइन ले तो इफेक्ट जानि पारे ना
We have to know the individual effect, na ma'am. So
हाँ the partial effect ना Bhakti ma'am told ना partial effect. Bhakti ma'am, you want to add anything to the explanation? Which
No,
is
sir, no, sir. This is okay. This is good,
now,
clear.
now Madhusita is asking a good question.
Each variable ର importance ଅଛି କି ନାହିଁ ଏଇଟା ଆମେ ଦେଖିପାରିବା each
हाँ
variable ର importance ଯଦି ଥିବ ଆମେ କେମିତି claim କରିବା ଏତେ ଗୁଡେ କାହିଁକି ଆମେ ନଉଛନ୍ତି because ସେ variable ର effect ଅଛି influence ଅଛି
ବୁଝିପାରିଲ
आज्ञा
ଯେମିତି ଆପଣ କହୁଛନ୍ତି ଗୋଟେ ପିଲାର ମାର୍କ ସେ କାହା କାହା ଉପରେ ଡିପେଣ୍ଡ କରୁଛି କେତେ ପାଠ ପଢୁଛି ରେଗୁଲାର କ୍ଲାସ ଅଛି କି ନାହିଁ ତା ଆଇକ୍ୟୁ ଲେଭେଲ କଣ ପ୍ରିଭିୟସ ସେକ୍ସନରେ ମାର୍କ କେତେ ରଖିଥିଲା ଏ ସବୁ ଗୁଡା ଭେରିଏବଲ ଇଫେକ୍ଟ ଯଦି ଅଛି ନା ଚେକ୍ କରିବାକୁ ଅଛି ତ ସବୁ ଭେରିଏବଲ ଗୁଡାକ ନେଇକି ଷ୍ଟଡି କରିବାକୁ ପଡିବ ନା ଆମେ ରାଣ୍ଡମଲି କହିପାରିବାନି କାହାର ଇଫେକ୍ଟ ଅଛି କି ନାହିଁ ତ ଏଇ ଅଧିକ ଭେରିଏବଲ ଏଇ ଗୋଟେ ହିଁ ହେଲ୍ପ କରିବ ତାପରେ ଆଡଭାନ୍ସ ଦେଖିବା ପାଇଁ ବୋଧେ ଆଡଭାନ୍ସ କଣ ମଡେଲିଂ ଥିବ ଆଉ ସାର୍ କହୁଛନ୍ତି ବେସିକ ଲେଭେଲଟା ସାର୍ କହୁଛନ୍ତି ନା
ହଁ ଏବେ ଏବେ ଆମେ ବେସିକ ରେ ଯିବା ବୁଝିପାରିଲେ କାରଣ ମୁଁ ଆସିବି ମୁଁ ଆପଣଙ୍କୁ କହିବି ଯେ ଆମେ ଇକୋନୋମେଟ୍ରିକ ରେ କ'ଣ ଆମେ ବେସିକାଲି ଏଠି କରୁଛନ୍ତି what we are trying to do I have not come to here means today we are just doing the math part basic mathematics which is required to understand econometrics simple but that will we will start econometrics later on not today okay ma'am
okay sir
because we will go for discussion means why we need lot of variables whether regression is causal regression means causality or not okay so these are the question of course we will discuss so that it will be clear but today in the section B we are only saying what is the application of linear function and how you will interpret this marginal effect of x on y is constant beta 1 is constant in a linear function across the data points that is what I am trying to say okay that is why you get a straight line isn't it Madhusida
यस सर यस
आमे एठी केवल लिनियर फंक्शन लो इंटरप्रिटेशन देखुछंती आ बीटा 1 को केमिति इंटरप्रेट करिवो द मार्जिनल इफेक्ट ऑफ x ऑन y केते अछि आ एटा कांस्टेंट रहिवो सेति भाई आमे स्ट्रेट लाइन पाउचंती बुझ पारलो कि नहीं क्लियर
यस सर
next we will go to so as we are having very less time let's try to proceed further what about the nonlinear relationship so now it is saying can you think of examples where nonlinear relationship might arise how do we write a linear function to describe a nonlinear relationship so because always we start with a linear regression model but most of the time nonlinear relationship we try to convert into a linear function right then we try to estimate it right which I think we will study how we will be using logarithmic transformation but let's say that this is quadratic function right you all know y is equal to beta naught plus beta 1 x plus beta 2 x square So although it is an important tool, but we don't begin to use quadratic function until I think we'll start with the regression, advanced regression, multiple linear regression. But how you can convert this nonlinear relationship into linear function? Simply you do the natural log transformation. Okay. So the log transformation helps you to convert a nonlinear relationship to write a linear function between y and x. Is it clear, Bhaktima?
Yes, sir. Clear.
So log transformation we use natural log. Natural log, the base is e. Okay. So which we write ln. Is it clear? And also sometimes we write log where the base is 10. Okay. So please be very clear about it. We use natural log transformation. Bhakti ma'am, is it clear?
Yes, sir. Clear.
Whenever we use ln, I am referring to my base as e, not 10. Okay. So let us try to understand how we will convert nonlinear relationship to linear relationship. So first, model of exponential growth or decay. So how we write? Yt is equal to y naught into e to the power bt. Okay, ma'am. So you can see over here, e or exponent. There are two standard way to represent the special number, that is 2.718. So if you will see over here, let us try to understand. Here you just go to Excel. I think, okay, I'll come to this one. Here. Bhakti ma'am, what we can do? You can see if there is a function called exponential function. Okay. Suppose let's say that if I will write 10. So what it is giving? Exponent of 10, right?
Yes, sir.
But if I want to know 2.718, so what I will write? Let's say that if I write 1, can you see?
2.7.
So we are getting
Yes, sir.
2.7182818, right? So usually our model is yt is equal to y naught, means the starting point, into e to the power beta t. Okay, that is a exponential growth model. So basically what we say, what we are trying to prove over here is our initial growth like population is started with let's say that 100. Okay, and our beta is 0.10. Okay, so now what we are trying to fit over here is how our t, when our t changes, means our time period changes, means the population at time t changes, how it will change, means how our population growth rate will change, means how our yt will change. And but from where I will get the equation, because already I know, you might be thinking from where beta is given to us. Okay, that is 0.10, and also y naught is also given to us. Is it clear, ma'am?
Clear.
Madhusudha, is it clear?
Yes, sir.
Now what you do in Excel, where you already have practiced the other you can say formulas for yesterday's function which I gave. So there you try to find out this, how I got this 110.517. Okay, Bhakti ma'am. So how I am trying to get over here is, first of all, you can see 100 into exponent. Already I told you exponent, what is the use of exponential function, right? Into 0.1 beta to t. 0 beta value is 0.1, already it is given to us. So I straight away I have written, but you can also use a cell or and freeze it. Rather than writing it like the way I have written, you can just write 0.1 and then you put the value C1 over there. That is better. And use the dollar sign. That is better. Okay, Bhaktima?
Yes, sir.
So that it is better, but I have just to avoid, means if someone will get confused, that is why I had written, but you can do it better way. Okay, not a problem. So 0.1 into beta B2. B2 is this one. T is equal to 1. Means the period is first period. Okay. Means now you just see, I got 110.517. So my yt, as already we know, it is 100 into exponent of 0.10 t. So that will give me 110.5171. Okay, Bhakti ma'am?
Yes, sir. Okay.
Madhusina, is it clear?
Yes, sir.
Now, let's say that I want to find out the rate of change. Means similar way I will go to the next value. Means when my t will be equal to 2. You just see how much I am getting? 122.140. Isn't it, ma'am? Are you trying it, Bhakti ma'am, or you will try it after the class?
I'll try after the class, sir.
Okay. So you just see over here. Now if you are having
sir.
any doubt, just you ask me.
Okay, sir.
So now my first of all, in the similar way, just I will change the in place of, you can see earlier I have taken B2 and here only B3. There is no other changes I have done in the formula. That is the best part. Once your formula start working, there is no need to panic to write the next formula. Simply copy and change the cell value, or you drag it, it will change. So then you got, when your t is equal to 2, y is equal to 122.1403. Now my, what is this? Okay, you can see this one is not calculated here, but I was trying to calculate. What I was trying to calculate is, suppose I was trying to use calculate delta, because the slope is what? Slope is delta yt upon delta xt, isn't it? So I was trying to find out a3 minus a2, that is delta y, upon delta x, that is 2 minus 1. So what I got? I got 11.62318. Okay. Now, so if you will see, I have converted the yt value, whatever I got, like in the, here also they have done ln yt, so I got 4.705. Okay, this one is just for my understanding. I was trying to see some point over here which you will get to know, but in the PDF only this one is done. Okay, so you just convert into using ln function. Okay, in Excel there is a ln function, directly you can convert it. Okay, so now you just see, so when I am actually not converting into ln, what is happening, I will show you. So just when I am writing exponential function, so you just see my beta is not constant. Okay, ma'am?
Changing it is.
So it is changing. Okay, it's much faster. Even though in the formula I have used, okay, but you just see it is changing because I am using linear function, right? I am not converted into a linear function, just when I am calculating. But the moment I convert into a linear function, you just see here. Here also I did the same thing. D3 minus D2, B3 minus B2. You just see. Now, once I convert into a linear function by taking a logarithmic value, so my slope is constant, is getting constant. Is it clear, Bhakti?
Right, sir. Yes, sir.
So that proof is given over here. Okay. So that is what it is saying. So it is saying the slope of yt is nothing but, you just see. So because if this is your yt equation, then what will be your dyt upon dt? It will be nothing but beta times y naught exponent of bt, that is nothing but beta yt. Okay. So basically your dyt upon dt is nothing but delta yt with respect to t, means delta t. So that is beta yt. It shows that, or it means that the change in yt per unit time is proportional to yt. Okay, and if we will multiply both the side of the equation by 1 by yt, so that is basically what we are doing. You are multiplying both the side. So obviously, so your delta final equation will be delta yt upon delta t into 1 upon yt will be beta. Okay, so the interpretation is here, this is most important, the proportional change in y per unit time is constant and it is equal to beta. Okay, so what we are trying to prove over here is, even though the relationship was nonlinear, we can use the natural log transformation, that is ln, to obtain a linear relationship in the transformed variable. Bhakti ma'am, is it clear?
Yes, sir. Clear.
I don't think it is very. Is there any complication?
Yes, sir.
Madhusudha, is it clear? Means why, how you will find out this? Is there any problem over here? Means how your slope is beta times yt?
Sir, I have small doubt, but after the class, I go through the material and try to understand.
No. Let me first tell you what it is written over here. Bhakti ma'am,
Yes, sir.
means if yt is written as y naught into e to the power, we will write in short, or exp into beta
E
t.
to the power beta t.
Okay. So you are asked to calculate
Dyt by dt.
dt. Then what is the problem over here? Means
No,
how
it is
I will write, Bhakti ma'am?
y0 is the constant, take it outside, then derivative of e to the power bt, that is equal to e to the power bt into derivative of bt with respect to t, that becomes b. Basically, the answer will be y0 into beta into e to the power beta t. See, y0 is a constant term here.
Y0 is constant, madam.
Yes. So you can easily take e to the power x formula will be used for calculating derivative. And here chain rule will be applied. Change in yt with respect to change in bt into change in bt divided by change in t.
I think Madhusudha, you are having a problem over here, right?
Yes, sir. Actually, I understand beta slope means changeness, but the exponential function case I do not relate it.
Means exponential function derivative you have not used earlier.
No, sir.
But Bhakti ma'am,
Yes, sir.
exponential function the
ମ୍ୟାଡାମ ୟୁଜ କରୁଛନ୍ତି ଏଇଟା ସିମ୍ପଲି ଏତେ ବେଳେ ଲେଖା ହେଇଛି ମ୍ୟାଡାମ ମତେ କନଫ୍ୟୁଜ ହଉଛନ୍ତି ମ୍ୟାଡାମ ଇକ୍ୱେସନ ଟା ଜଷ୍ଟ ଏମିତି ଭାବନ୍ତୁ y ଇକ୍ୱାଲ ଟୁ a ଇଣ୍ଟୁ e ଟୁ ଦି ପାୱାର bt ଯୋଉଟା କି a କନଷ୍ଟାଣ୍ଟ b କନଷ୍ଟାଣ୍ଟ ଏବେ ଡେରିଭେଟିଭ କାଢିବେ ଯୋଉ y0 e ଟୁ ଏକ୍ସପୋନେଣ୍ଟ ପାୱାର bt ଏମିତି ଲେଖା ବେଳକୁ ମେ ବି କନଫ୍ୟୁଜ ହଉଛନ୍ତି ଅଦରୱାଇଜ ଏଟା ତ ବେସିକ ଡେରିଭେଟିଭ ଟା ହବ ମ୍ୟାଡାମ କିଛି ବ୍ୟସ୍ତ କରନ୍ତୁନି ଟିକେ ଆପଣ ମ୍ୟାଡାମ ଯାହା କହୁଛନ୍ତି ଠିକ କହୁଛନ୍ତି ସେ ଟିକେ ମ୍ୟାଟେରିଆଲ ଯାକ ଦେଖି ଗଲେ ଧୀରେ ଧୀରେ ସେ ଶାନ୍ତ ମନରେ କଲେ ଅଟୋମେଟିକ ଡେରିଭେସନ ଟା କରିଦେବେ ଦି ଲାଇନ ର କଥା ତ ଆଉ
Yes, sir. Yes, ma'am.
means you should be able to find out the slope is beta times yt. Okay, and what is the interpretation? What it is saying? dyt upon dt is equal to delta yt upon delta t, which will be equal to beta yt. That is, the change in yt per unit time is proportional to yt. Okay, I think if you have remember, last semester we did a log transformation elasticity calculation. Okay, so
Yes, sir.
now don't think complicated ways, but likewise Bhakti ma'am told, simply you try to calculate it. I think Bhakti ma'am, because y naught is a constant over here,
should be
you
taken
can,
outside.
you can keep it outside, right?
Yes sir.
There is no problem.
Yes sir.
Ma'am, we are simply using the exponential function rule or the exponential functions rule with the chain rule.
Exponential function rule with the chain rule because we have to calculate dyt with respect to t but here e to the power bt is mentioned.
Okay, 1 minute. 1 minute.
Yes sir.
Okay, ma'am. Okay.
Say, I think last time also similar problem we did. So it is not a very complicated. So Chinmay, are you able to do it?
No, sir.
Why no? Everyone is saying no, Bhakti ma'am.
आपको खाली एटा गोटे सिंपल फॉर्म रे लिखि दे दियंतु y इक्वल टू 3 e टू द पावर 2t तार डेरिवेटिव काढंतु से करके जानि परिबे तापर जस्ट 2 जागा रे y0 3 जागा रे b पकई देबे सेही बाट पाइबे सेही आंसर पाइबे
मैम कहले कहार डेरिवेटिव्स बाहर करिबार
y
अछि
इक्वल टू 2 into e टू द पावर 3t
रुहतु मैडम मैडम मु कर दउछि
हां सर
सेटा बेटर होचे आपण देखंतु मु करूछि नो प्रॉब्लम so 1 second, I think it is getting little slow. One second. Okay, so let me, I am writing it over here. Okay, so what you are having yt as y naught exponent of bt, correct? So what you have to do is you have to differentiate with respect to t, right? So we are basically calculating dyt with respect to dt, right? Ajay, are you writing it down?
Yes, sir.
So you write like this: y naught into exponent of bt. Right, Bhakti ma'am, please check. Okay,
Okay, sir.
because since y0 or y0 is a constant, and if you will apply the chain rule over here, so it will be dyt upon dt, that is y0 into exponent of beta t into beta t derivative, right, Bhakti ma'am?
Right, sir.
That is beta, because we are differentiating with respect to dt, correct? So that is how you got beta into y0 exponent of beta t. Now what you have to do is, so now because already we know our yt is equal to y0 into exponent of beta t, so dyt with respect to dt will be equal to, which already we got this, right? So in place of this you are simply writing yt, right, Bhakti ma'am?
Yes, sir.
Or is there any mistake?
No, sir.
So that is why we have written this final. So what is the problem? I was not getting. Is it clear, Ajay?
A little bit. I will say it, sir.
Means where is the problem? Bhakti ma'am, can you just explain? Yeah?
Chain rule.
No,
Yes,
where is the problem, Ajay?
sir. Just we applied the chain rule there after this line, sir. Beta into y naught exponential of bt.
Means if you will apply the chain rule, what is the problem over here? Bhakti ma'am, how
Yes, sir.
we will explain this? Why not into exponent of beta t?
Okay.
Till here it is clear, right, Ajay?
Yes, sir.
Then you are not getting how we got.
I got it, sir, due to application of chain rule, but some complications. Sir.
Okay. Bhakti ma'am,
Yes, sir.
can you just help Ajay sir?
मैम टिके ओडिया କହିଦିଅନ୍ତୁ ମ୍ୟାମ୍ ବୁଝା ପଡିଯିବ।
ସାର୍ ଶୁଣନ୍ତୁ, ଏଠି ଆମେ ଯୋଉ ଡେରିଭେଟିଭ ଅଫ y କାଢୁଛନ୍ତି ୱିଥ ରେସ୍ପେକ୍ଟ ଟୁ t, ବଟ୍ ଇ ଟୁ ଦି ପାୱାର ଆମର ଅଛି ବିଟା ଇଣ୍ଟୁ ଟି, ରାଇଟ୍? ମୁଁ ଏଠି କଣ କରିବି, ଯୋଉ ଚେନ୍ ରୁଲ୍ ପକେଇଲେ ଡେରିଭେଟିଭ ଅଫ y ଟୁ ୱିଥ ରେସ୍ପେକ୍ଟ ଟୁ dy2 divided by dbt into dbt divided by t dt। ତ ଡେରିଭେଟିଭ ଅଫ bt କ୍ୟାନସଲ ଆଉଟ୍ ହେଇଗଲେ ଅଲ୍ଟିମେଟଲି ମୁଁ ତ ସେଇଟା ପାଇବି ନା, ଡେରିଭେଟିଭ ଅଫ yt ୱିଥ ରେସ୍ପେକ୍ଟ ଟୁ t। ଲାଷ୍ଟ ମୁଁ ଆକୁ ଚେନ୍ ରୁଲ୍ ବୋଲି କହୁଛି। ଏବେ କାଢନ୍ତୁ ଆଗ, y0 କନଷ୍ଟାଣ୍ଟ ଟର୍ମ ବାହାରକୁ ନେଇ ଆଇଲେ, ଇ ଟୁ ଦି ପାୱାର bt with respect to bt ଡେରିଭେଟିଭ କାଢନ୍ତୁ, ଇ ଟୁ ଦି ପାୱାର x ଡେରିଭେଟିଭ ଇ ଟୁ ଦି ପାୱାର x।
ମ୍ୟାଡାମ ଗୋଟେ ମିନିଟ,
Yes, sir.
ମୁଁ ଏବେ ଗୋଟେ କାମ କରୁଛି, ଅଜୟକୁ ଟିକେ ଆପଣ ଯୋଉଟା କହୁଛନ୍ତି ତାକୁ ଆମେ ରିଲେଟ କରିବା ପାଇଁ ସିମ୍ପଲ ଗୋଟେ କହୁଛି। ଯଦି ଆମେ ମାନିନିଅ ମ୍ୟାଡାମ ଦେଖନ୍ତୁ, ଯଦି ଆମର ଏମିତି ଗୋଟେ ଜିନିଷ ଅଛି, ଫଙ୍କସନ ଯଦି ମାନି ନିଅନ୍ତୁ, ଯଦି ଅଛି ଇ ଟୁ ଦ ପାୱାର 3t ଅଛି ମାନି ନିଅନ୍ତୁ, ତାହେଲେ ଆମେ କେମିତି ଏକୁ ଡେରିଭେଟିଭ ବାହାର କରିବା? ଫାର୍ଷ୍ଟ ଆମେ ଆଉଟସାଇଡ ଫଙ୍କସନ କୁ କରିବା, ରାଇଟ? ଆଉଟସାଇଡ କଣ? ଇ ଟୁ ଦ ପାୱାର ଯୋଉଟା ଅଛି, ଯୋଉ ଫଙ୍କସନ ସେଟା ହଉଛି ଆଉଟସାଇଡ ଫଙ୍କସନ, ବୁଝିପାରିଲ କି ନାଇଁ ଅଜୟ? ଇନସାଇଡ କଣ ଅଛି? ଏଇଟା ଅଛି, ଏଇଟା ହଉଛି ଇନସାଇଡ ଫଙ୍କସନ କୁହନ୍ତି, ରାଇଟ? 3t ଟା, ରାଇଟ? 3t ର ୱିଥ ରେସ୍ପେକ୍ଟ ଟୁ dt କେତେ ଡେରିଭେଟିଭ ହବ? 3 ହବ ନା?
3
ହବ ନା ହବନି?
yes sir, हाँ 3।
ଆଉ ଇ ଟୁ ଦ ପାୱାର ସମଥିଙ୍ଗ ର ଡେରିଭେଟିଭ କେତେ ହବ? ଇ ଟୁ ଦ ପାୱାର x ହବ ନା, ଇ ଟୁ ଦ ପାୱାର x ର ଡେରିଭେଟିଭ ହବ ନା ହବନି?
हाँ सर, e to the power 3t
अरे
into
मैम, भक्ति मैम, e टू द पावर x ର ଡେରିଭେଟିଭ କଣ?
ଇ ଟୁ ଦି ପାୱାର x।
e to the power x
तो तमे माने समस्त कोन जानि ना कोन एक्सपोनेंशियल फंक्शन ला डेरिवेटिव टा एक्सपोनेंशियल फंक्शन बोली तो सेटा तो मु कहूची मु आ कोन अधिक किछ कहूची ना कोन
ଏଇଠି x କହିଲେ ତାର x ଇକ୍ୱାଲ ଟୁ 3t ନେଇଛନ୍ତି।
हां x इज
हाँ
इक्वल
हाँ 3t टा हाँ 3 टा बाहर को पड़े आसबो और e t टा खाली रह
मु एठी दुईटा जिंस कहूची e टू द पावर 3t होची गोटे फंक्शन जोटा कि आउटसाइड फंक्शन बुझ पालो भीतर कोन अछि 3t टा होची इनसाइड फंक्शन हैला आउटसाइड माने होल एटार डेरिवेटिव होची e टू द पावर 3t हैला
हाँ हाँ जेमति हम चेंज ले
भीतर डेरिवेटिव होची 3 हैला राइट
यस
तो तो ताले कोन हैला तो यार जदि डेरिवेटिव हम बाहर करले ताले हम केमिति लिखबा e टू द पावर 3t लिखले फर्स्ट आउटसाइड फंक्शन लो डेरिवेटिव इनटू इनसाइड फंक्शन दैट इज 3 टाइम्स e टू द पावर 3t हैला ना
आज्ञा
ना हैला नी
हेला सर
तो से तो सेम वे रे हमें सेठी भी तो करूचंती ना
हाँ हाँ
सर
हाँ
सर जो एक्सपोनेंशियल जो लेखाटा जो रहूची सेथमें सर टिके कंफ्यूजन थिला एबे सर सेटा जदी हम डायरेक्ट लिखि देबा y नॉट तर एक्सपोनेंशियल और बीटी लिखि देबा सर हे जिवो ना सेमिति
e टू द पावर बीटा t तो आ कोन हेतु लिखियार कोन अछि exp सेठी लिखा है न e टू द पावर बीटा t लिखि दो
हाँ बेटा
हां सर बुझियला
हेला सर हे गला सर बुझे
नहीं कि भक्तिमान
यस सर।
हाँ e to the power bt तो अच्छे हाँ हे जीवो सर हाँ
नहीं नहीं है जीव कोन तमे करबो ना है जीव
हाँ हेला सर बस एक्सपोनेंशियल से लिखा आइथिला तो सो दैट्स व्हाई माने हम भाबिलो कि e to the power bt अछि बट जदा चेन रूल अप्लाई हला से तापर ठीके प्रॉब्लम हला हो माने e to the power ux रो हम जेमति बाहर करूछु u into तापर एमति करी कि जो बाहर करते एक्सपोनेंशियल फंक्शन सेमति ही बाहरिबो
ओके एटा देखो हम तो करूचे नाउ इट विल बी क्लियर एटा देखो फर्स्ट जो सी हमर एठी कोन अछि फर्स्ट यू ट्राई टू अंडरस्टैंड हमरा आमे एमिति लिखुछन राइट भक्तिमान जोटा बुझे पे चेष्टा करथले जेहेतु मैडम लिखि पर नांती मु लिखुची मैडम कहिबे व्हाई नॉट आमे e xp जोटा लिखुछंती तो एटा e टू द पावर बीटा t भी एटा हम लिखिबा नहीं कि e टू द पावर मु कोन करिबी बीटा t लिखिबी नहीं कि मैडम लिखि पारिबी ना मैडम
हाँ सर हाँ।
एटा लिखिबी एमिति लिखिबी बुझ पारला
यस सर
तो फर्स्ट
सर एटा सर
y नॉट टा कोन मु तुमको कहूची y नॉट टा होची गोटे कांस्टेंट
कांस्टेंट तो
आउ
ताको
एटा होची गोटे एक्सपोनेंशियल फंक्शन जोटा मु तुमको कहूची जोटा हमर अनचेंज्ड रहइबो e टू द पावर बीटा t जोटा होल पूरा आउ इनसाइड रे कोन रहउची बीटा t रहउची एटा होची लीनियर फंक्शन हला तो एटे दीटा फंक्शन अछि गोटे एक्सपोनेंशियल फंक्शन अछि इनसाइड टा अछि लीनियर फंक्शन बोथ आर t with respect to t हला माने लीनियर फंक्शन टा लीनियर फंक्शन ऑफ t हला तो बर्तन यार जदि आउटसाइड फंक्शन लो जदि हमें डेरिवेटिव बाहर करबा e टू द पावर बीटा t तो सिमिलरली रहइबो बुझ पालो तो बर्तन हमें कोन करबा चेन रूल हमें स्टेप बाय स्टेप बाहर करबा हला फर्स्ट लेखो एमति लेखो y नॉट इनटू e टू द पावर बीटा t दैट इज डेरिवेटिव ऑफ आउटसाइड फंक्शन जेम तुमको कहितली आगुरु नहीं कि इनटू इनसाइड फंक्शन केते बीटा बीटा बना विथ रेस्पेक्ट टू dt तुम बाहर करछो बीटा t राइट बीटा t रो डेरिवेटिव केते बीटा ना
बीटा
राइट तो ताले कोन हला ताले हमर हला बीटा बीटा इनटू y नॉट e टू द पावर बीटा t हला कि नहीं हला ना
हाँ हे गला सर
तो प्रॉब्लम कोन होची मु बुझी पाउनी
କିଛି ନାହିଁ
सर
sir, ହଁ।
लेखा इतला बोले हम
हाँ
हैं
जो EXP ଜାଗାରେ ଆଗରୁ E ଲେଖି ଦେଇଥିଲେ ସେମାନେ ବୁଝି ଯାଇଥାନ୍ତେ। ବେଶୀ ଗୋଟେ ୱାର୍ଡ ଲେଖିଲା ବେଳକୁ ମେ ବି କନଫ୍ୟୁଜ
हाँ हाँ
ହେଇଯାଉଛନ୍ତି।
हाँ तापरे जो y टा कांस्टेंट थिला y टा जो बाहर को पड़े आसला सेथिरे टिके कंफ्यूजन होतिला
अच्छा 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 सो नाउ नेक्स्ट स्टेप जोड़ा कहूँ जे मल्टीप्लाई बोथ द साइड बीटा वाई टी तो हमें बुझिल राइट बीटा वाई टी केमिति हूँ स्लोप राइट आमर कौन एटा द इंटरप्रिटेशन कौन आर इंटरप्रिटेशन हूँ जे change in yt per unit of time that is proportional to yt. Now what you will do is you will multiply both the side माने आमर कौन अच्छी डेल्टा yt आम एमती लिखा डेल्टा yt अपॉन डेल्टा t we got बीटा yt आम एबे मल्टीप्लाई करदवा कौन both the side 1 by yt रे हैला तो करदेले कौन बाहर बीटा हम ना नहीं कि एटा आसीबो ना यस और नो चिन्मय
ଆଜ୍ଞା ସାର୍ ହଁ ସାର୍ ଆସିବ
भक्ति मैम तो आम लिखा प्रोपोर्शनल चेंज इन y पर यूनिट टाइम इज कांस्टेंट इक्वल टू बीटा सो दो नॉन लीनियर वी कैन यूज नेचुरल लॉग ट्रांसफॉर्मेशन ln to obtain linear relationship in the transformed variable सेटा से हम कहते now recall or note algebraic rule for the natural log function natural log function रे जदि तमे भूली जाइथो एडा सब माने होची अगेन मने पकाओ ln ab multiplication rule एटा division rule ln a to the power c c to the c times ln a ln e सारा वैल्यू होची 1 right e to the power ln x will be x ln x is undefined जदि लेस देन नेगेटिव नंबर पाई कि 0 पाई ln ले तमे कन्वर्ट करि परिबो नाही ताले एठी देखो दे एठी गोटे होची से गोटे एग्जांपल देछि नाउ अप्लाई दिस रूल्स टू ट्रांसफॉर्म yt इक्वल्स टू 100 into e to the power beta t तमे कोन करो ln बोथ द साइड नहीं जाओ हैला नेला पर तमे एटा ए इक्वेशन ता तमर रहइला नहीं के तो लास्ट इक्वेशन कौन रहला ln yt will be equal to ln 100 plus beta t now question से कहूँ जे so that there is a linear relationship between ln yt with respect to t okay जोटा एक्सेल ले देखो मो बाहर करथिली हमर जो लीनियर रिलेशनशिप केमिति एट हेछि एक्सपोनेंशियल फंक्शन देखो सबुतिर सेम हमर बीटा आसिला that shows that we have transformed the non-linear relationship to linear relationship is it clear हमारा डायग्राम देखो तो भक्ति मैम so when you will plot these two diagrams
It's a straight line.
so first case before transformation before the natural log transformation you will get the diagram like this
Yes.
after you do the linear transformation you will get the diagram like this and why you are getting because of this logic because the slope is not constant in the first case but after you transform into a linear relationship then the slope remains the constant so you can see over here it is written clearly over here t has a constant marginal effect which we have started how we will interpret the beta marginal effect on ln yt with the slope being slope का हमारा कौन delta ln yt upon delta t is nothing but beta so हमारा delta ln yt represents a proportional change in y per unit of time okay so in the first example in the population example beta we took as 0.10 so 0.10 interpretation is 0.10 proportional change in y per unit of time. Time can be year or it can be month. Is it clear? The first part of log function. Natural log transformation is very important. Bhakti ma'am.
Yes, sir. Yes, sir.
First model is model of exponential growth or decay. This model.
Yes, sir.
This model you have to use Excel and you have to show me this graph
Yes, sir.
and this whole concept.
Okay,
It's
sir.
how the slope without transformation is not constant.
After transformation.
How the after the transformation how it is constant.
Yes, sir.
Sir, can you explain after transformation what is actually happen?
Result is before you only. After transformation, what has happened? We have converted na into log. Means after we use the natural log transformation, what has happened? You just see
beta will be
this
constant.
this thing we did, right? Your yt here it is without transformation. Once you do this, you just see the difference. Okay, and if you see the difference, you will be able to see how much changes has happened, right?
Yes, sir.
Because what it is saying that though non-linear, we can use natural log transformation ln to obtain a linear relationship in the transformed variables. Okay, so this thing you have to try with an example. Okay, the first one another example, and this one you have to try. What you will do, this is a non-linear function. You take ln both the side, you will take the log both the side, then applying the natural log function rule, you get this, right? So now the question is that whether there is a linear relationship between ln yt and t, right? This is a question. Now from here you can easily see, right? You have to plot it. I think I did it here. So plotting also I did. Let me show you. Somewhere it must be there. Okay, 1 second, Bhakti ma'am. Non-linear function. Can you see ma'am here?
Yes, sir. Yes, sir.
So this is how
Why
I
there
did
that is?
actually.
Yes.
So after I convert, you just see here.
Okay. Data.
So after I convert, okay. So everywhere the delta is 0.1 only.
Right.
But I have not plotted. But if I'll plot it, then definitely it will be like that.
Linear.
Okay. So without plotting yt, I can plot it. So we can try, not a problem. But what is our x? I'll show it. It will take little time. T and y we have to plot, right? Let me show you.
Right.
So if we will plot our t and y, right? So you just see. This is our y. So go to insert. Go to insert. One is I will be using. Just see.
Okay, sir.
Can you see?
Yes, sir.
So this is your t and this is your yt. So how it is growing?
Exponentially.
Exponentially growing, na Ajay?
Yes, sir.
And how our graph was? Our graph was also similarly it was growing, isn't it? Yes or no?
Yes,
Yes,
sir.
sir.
Then similarly you just plot. What you do is you
Log what?
select this, then you put control key, then you select this one, then insert, go to line, just see
Okay. Straight.
ln yt is a, because this one I can delete. ln yt just I want to
Yes.
plot it, isn't it? That is becoming straight line only.
Yeah.
Yes or no?
Yes,
Yes,
sir.
sir.
but not exactly. I have not got like this because little I have to adjust the graph. Which here I am starting with like you can see vertical axis. I will format the axis. Minimum value is here. They have plotted minimum value is 4.5.
4.5.
So then only it will be clear. Means and maximum value it is 7. Okay. Okay. See, it will be little adjusted. Okay. Then only it will be like this only. And here also we have to take 5 year gap. Okay. Then the graph will be adjusted. You can try in Excel and show it to me.
Okay, sir.
But you know how we are getting, that is most important. Means the equation. First part is first part is natural log transformation, and then how the slope is getting affected, and then the second part, the constant elasticity function. Okay. Then we will be going to the second part, third part. Means the interpretation of proportional change using natural law. So there are 3 parts, Bhakti ma'am, to this question. Then this whole PDF will be clear. So I think the first part is the math part, and the second part is the plotting you can do. Second part is the constant elasticity. So math, if you will understand, I think you can understand the rest of the things. I think tomorrow, like if there will be any time, like math part, I think Bhakti ma'am, we can use do the like you can use the board to understand, right? But I think if you will read and practice it in Excel, it will happen.
Yes.
And still, if there is any doubt, please let me know. I will try to do it in the class itself. मतलब लाଗୁଛି ପିଲାମାନଙ୍କ ପାଇଁ ତ ବହୁତ ଟଫ୍ ହେଇଥିବ ଯୋଉମାନେ ଜଏନ୍ କରୁଛନ୍ତି ନାଇଁ କି?
ସେମାନେ ଟିକେ ଦେଖିକି ଏକ୍ସେଲ ଟିକେ ଟିକେ ପ୍ରାକ୍ଟିସ କଲେ ହୁଅନ୍ତା। ବେସିକ ଜିନିଷ ସମ୍ ବାହାର କରିବା, ପ୍ରଡକ୍ଟ